Describe the transformations of f of x to g of x, then graph the functions. So f of x equals 1/3 to the x power. G of x equals negative 2 times 1/3 to the x minus 2 power. So transformations, we have this negative sign, which means x-axis reflection. And this 2 means a vertical stretch by 2. And this x minus 2, the negative 2 up here, means a translation of right 2. Okay, those are our transformations. Now I'm going to graph f of x equals 1/3 to the x, simple input and output table. I'm going to use -1, 0, and 1 for the inputs. And 1/3 to the -1, that's actually 3. So do the reciprocal of 1/3. 1/3 to the 0 is 1, and then 1/3 to the 1 power is 1/3. Okay, so -1 and then 3 is right there. 0, 1, 1, 1/3. And also, if you look at this function, you can see that it's an exponential, and the base is between 0 and 1. Exponent's positive. This means you have exponential decay. That means there's going to be a horizontal asymptote here along the x-axis. And when we draw our function, it's going to look like that, more or less. So now come the transformations. First of all, I'm going to do the vertical reflection. So if I do that, that's what the function would do. But there's more. There's a vertical stretch by 2. So let me get a gray color here, see if that works. So I'll stretch everything by 2. We're just multiplying the outputs by 2. So then it would do this. Then there's a translation of 2 to the right. So translate each point that I plotted. Okay, so that's basically what the function should look like. Now let's get a graphing calculator and verify. Then -2 times 1/3 to the x minus 2 power. And let's graph. So there's f of x. And there's g of x. And that looks like a good match to what I drew by hand, so I know my graph is accurate. And that also I had the right transformations. So aside from the colors being different between red and black here, looks really good. So here are my transformations. X-axis reflection, vertical stretch by 2, translation of right 2.